Hi everyone, in this video we will be learning about linear equations with fractional coefficients as well as fractional equations. Let us recall what expressions, variables, terms, and coefficients are. In this example, we have negative 5x plus 6xy minus 3 over 2y plus 2.39z plus 7. This is what we call an algebraic expression. In this algebraic expression, there are actually 5 different terms, and the 5 terms are negative 5x, 6xy, negative 3 over 2y, 2.39z, and 7. Notice that when recognizing the terms, if it is actually a positive number, we usually don't mention the positive part. Unlike when it is negative sign in front or a minus sign in front, we will put that negative sign into the term itself. There are actually 3 variables in this algebraic expression. We have x, y, as well as z. Looking at each of the term, let's say negative 5x, which is our first term, the coefficient is negative 5. Coefficient refers to the number found in front of the variable, and in this case, the number found in front of the variable is negative 5. Do recall that we have already learned what are negative numbers, so negative numbers are also considered a number. Looking at the next term, 6xy, we have the coefficient 6. And in the next term, negative 3 over 2y, the coefficient is negative 3 over 2, since the number in front of the variable y is negative 3 over 2. And then, looking at the term 2.39z, the coefficient is 2.39. I want to emphasize that in these terms over here, the coefficients need not always be integer numbers or whole numbers. They can always take the form of rational numbers, such as negative 3 over 2 or 2.39. And in the last term, 7, that is actually a constant term because there are no variables involved. It is just a number itself. Hence, there is no coefficient or variable to mention in a constant term. Let us recall how to solve an equation. In this example, we have 3x minus 7 equals to 4 minus 8x. This is what we call an algebraic equation, or more specifically, it is a linear equation. So in solving any equation, our objective is to always place all the terms involving x to be on one side of the equal sign. Usually I'll place it on the left, and all the other numbers to be placed on the right side of the equal sign. So in this equation, 3x minus 7 equals to 4 minus 8x. Let us just copy that question down. What we aim to do is to transfer this minus 8x. Let me change into a pointer. So this minus 8x over here, I want to kind of shift it over to the left side because that is our objective, where I want all my x to be on the left side. So having this minus 8x over to the left side, that means that I'm adding a 8x on the right as well as adding a 8x on the left side. So previously we have already learned that I do not need to actually show every single step in trying to balance the equation. We know that it is as good as doing 3x plus 8x equals to 4 plus 7. Why is it a 4 plus 7? Because I am also doing this minus 7 on the left side over to the right side. So I'm just trying to do 2 steps over here. Let me just grab a pen. I'm trying to shift this minus 8x over to the left side. That gives us a plus 8x. And also, I'm trying to shift this minus 7, over to the right side. And that results in a plus 7 on the right side. So whenever we shift across the equal sign, we do the opposite operation. So what we earlier saw is that this is a minus 8x. When I'm trying to shift it over the equal sign, it becomes a plus 8x. And in this minus 7 over here, when trying to shift it over to the right side, it becomes a plus 7. That's why we achieve a 3x plus 8x equals to 4 plus 7. This will be a more elegant way of presentation, reduces the steps. Then 3x plus 8x equals to 11x. And then 4 plus 7 equals to 11. So from this step to this step, we have 11x equals to 11. And then finally, we are going to divide this 11. Why do we divide? Because this means 11 times x. So when trying to transfer or bring this 11x, or rather 11, over to the right side, okay, I need to break out the times found in between 11x, and then we do this 11, divide by 11 over here. So x equals to 11 over 11, and that gives us a value of 1 as our final answer. In this example, we are trying to solve 5 over 2x plus 3.5 equals to 2 over 3x plus 5. So to begin, let us first copy down what the question wants us to solve. So in this equation, since our objective is to solve the equation, okay, we need to shift our x, okay, that is currently found on the right side over to the left, and the numbers that we have on the left side over to the right. So this 2/3 x is actually a positive 2/3 x. So we are trying to shift it over to the left. And since it is positive now, by bringing it over, it means that I need to do a minus 2/3 x. Likewise, this current positive 3.5 that's found on the left side, to bring it across to the right side, it will have to become a minus 3.5. So therefore, in our next step, we will write 5 over 2x minus 2 over 3x equals to 5 minus 3.5. So what I've done here, just to reiterate, let me grab a pen. What I've done is that this is a positive 2 over 3x. So I'm bringing it over to the left, hence I'm getting this minus 2 over 3x. And then this positive 3.5, I'm bringing across to the right side, hence I have this negative 3.5. So I can calculate 5 over 2x minus 2 over 3x, in this case using a calculator. So I press into my calculator, 5 over 2 minus 2 over 3. I just do away with the x, okay, just drop the x in my pressing of calculator, and I will find that it is 11 over 6x. Strictly speaking, you will likely have encountered that it becomes 6 and 5 over, 1 and 5 over x. Sorry, I meant to say, my apologies, let me grab a pen first. Okay, when you press in your calculator, 5 over 2 minus 2 over 3, in your calculator, you will likely get 1 and 5 over 6. Okay, but usually for coefficients, this number over here is what we call a coefficient since it's in front of x. We don't write our coefficients in a mixed number. So this is a mixed number. We usually write our coefficients in improper fractions. Therefore, I have 11 over 6x equals to 1.5. How I got this 1.5? It is by taking my calculator again. I take 5 minus 3.5. Okay, please make full use of your calculator. You do not need to show any step-by-step working. Okay, so 11 over 6x equals to 1.5 now. 11 over 6x is none other than 11 over 6 times x. So in our next step, what we need to do is to bring this 11 over 6 over to the right hand side. And because it is actually a multiplication, so I'm just going to put this squeeze this x over here, or rather squeeze this multiplication sign over here. To bring it across, it means that I have to do a division. So I need to take 1.5 divide by 11 over 6. So let me just clear away these writings that I have, okay, so that I can show you my next step. Okay, so in the next step, I will have x equals to 1.5 divided by 11 over 6. Okay, so I want you to see that I have here a division sign that is opposite of multiplication. Then we just have to press into a calculator for 1.5 divided by 11 over 6, and I will be able to get the final answer of 9 over 11. So the answer to this question is x equals to 9 over 11. We now take a look at trying to solve this example here, which is z plus 2 over 3 equals to 3z plus 2 over 5. In trying to solve this question, I'm going to first present to you an answer that is longer in method so that you can understand why I do the shorter method in the end. Okay, so in this question, we have z plus 2 over 3 equals to 3z plus 2 over 5. So I'm just copying down the question first. We know that whenever we solve an equation, we want all the algebra z, okay, or the variable z to be placed on the left side and all the numbers to be placed on the right side. However, we see that currently on the right side, we have 3z plus 2, that is everything placed together, and then divide by 5. Okay, so 3z plus 2 is together on its own, okay, then divide by 5. So the thing that I need to get rid of first is this divide by 5 on the right side, okay, so that then I can bring out the 3z and place it on the left, which is our objective here. So when dividing by 5, okay, what we will do in bringing over to the left side is that to neutralize the division of 5, we will usually multiply by 5 on the right side and multiply by 5 on the left side. So this is what I see on my next step of working, where I multiply by 5 and multiply by 5. Because this multiplication of 5 and this division of 5 neutralize each other, in other words, I'm cancelling each other out, so that in my next step, okay, the left side remains unchanged as z plus 2 over 3 times 5, and on the right side, I only have 3z plus 2. So I no longer have the 5 hindering me from trying to shift my 3z over to the left side. Okay, but before we even try to shift the 3z onto the left side, let us first also try to remove this divide by 3 on the left side. So by the same method, I'm going to multiply by 3 on the left side and multiply by 3 on the right side. Because as mentioned previously, I know that this 3z plus 2 is together as a group, so I must put these brackets around this 3z plus 2, okay, before I multiply by 3. Then this divide by 3 over here and this times 3 over here, they cancel each other out such that I'm going to get z plus 2 times 5 equals to 3z plus 2 times 3. So it took us quite a number of steps for us to arrive at this stage here. Okay. Now, later on, I will be showing you a shorter set of workings such that I can immediately arrive from this step to this step. Okay, but I want us to keep in mind what we have tried to achieve. So in doing all these steps, what I've tried to do is to actually so-called remove the ideas of fraction, okay, so that it is easier for us to go about solving and arrive at something familiar for us. So from this step here, it is the same as writing 5 bracket z plus 2 equals to 3 bracket 3z plus 2, since the brackets also act as multiplication. Then we know that we need to do some form of expansion, okay, in order to get rid of the brackets. So 5 times z will give us 5z, and 5 times 2 will give us plus 10, equals to 3 times 3z, that will give us 9z, and 3 times 2 will give us a plus 6. So that is by doing our rainbow method, or formerly known as distributive law. So let me just bring out my pen here, okay, so that I can try to show you the exact steps in case you're still not familiar yet. So I'm doing 5 times z and 5 times 2, and then 3 times 3z and 3 times 2. That allowed me to get this 5z plus 10 equals to 9z plus 6. Okay, then now we have arrived at something familiar. I want to now shift this 9z, which is a positive 9z. Let me change to a pen again. This is a positive 9z, and I want to shift it over to the left side. Likewise, I want this plus 10, okay, shifted to the right side. So I will have 5z minus 9z equals to 6 minus 10. Maybe perhaps let me just color code things. Okay. So this positive 10, I'm trying to shift it over to the right, which resulted in this minus 10 here. And earlier on, for this positive 9z, when I shift it over to the left, I'm arriving at this minus 9z when I cross the equal sign. So with 5z minus 9z equals to 6 minus 10, I can simplify 5z minus 9z into negative 4z and 6 minus 10 to be negative 4. Then, as previously mentioned, there is a secret multiplication sign over here. So this negative 4, when I'm trying to transfer it over to the right side of the equation, I will have to do a division. So in my next step, I'm looking at z equals to negative 4 divided by negative 4. Let me just clear up this part in order for us to see better. Okay, so that's why I have this division of negative 4, okay, found in this step. Therefore, I conclude that z will be equals to 1 itself, because negative 4 divided by negative 4 is equals to a positive 1. So this is the lengthier method. Okay, next I will be showing you the shorter method. Let me now present to you a simpler set of working that will help us to solve this equation more efficiently. Okay, so earlier on when trying to solve this equation, let me just go back, okay, to show you what was the previous working like. Okay, so this was the previous set of working. What we did was we multiplied by 5 on both sides of the equation in order to get rid of this 5. And then also we multiply by 3 on both sides of the equation in order to get rid of this 3. Okay, so we had a few steps over here in order to arrive at this 5 times z plus 2 equals to 3 times 3z plus 2, which is something familiar for us to actually proceed in solving. Alright, so instead of doing this tedious multiplication of 5 and multiplication on 3, let's do this simultaneously, meaning to say we do it at the same time. So in my new set of working, what I want to show you is that given this original question, okay, we will do this thing called cross multiplication, where I'm going to take the 5 to multiply with the z plus 2 and the 3 to multiply with 3z plus 2. Okay, so this method itself is what we call cross multiplication, and I want us to take note that it only applies when the equation is in the form of a single fraction equals to single fraction. In other words, right, let me just grab my pen here. Okay, your equation itself must be of the form whereby you can have anything, okay, above on the numerator of the fraction equals to anything at the bottom, and then we can have, let's say, a heart shape over here to represent something, okay, and then after that maybe a rectangle. Okay, so it must always be a single fraction equals to a single fraction, right? Which in this case, our question does satisfy it because we have a single fraction here and a single fraction over here. Okay, just one fraction over here. So it cannot be, okay, to maybe illustrate to you, okay, it cannot be something like having something, a fraction, plus another fraction, trying to draw a heart shape over here, and then after that, a single fraction again. Okay, sorry, I'm running out of shapes, so let me just show it like that. So we cannot apply cross multiplication when our equation is in this kind of format, okay, because there are actually two fractions over here, and then there's only one fraction over here. So therefore, the idea of single fraction and single fraction must be there in order for us to do cross multiplication. Okay, so when we do our cross multiplication, let me go back to my laser pointer. When I do my cross multiplication, what I'm trying to do is I take this 5 to cross over to the other side and multiply with this thing on the numerator, z plus 2. So from the denominator, I cross over to the numerator and I multiply. That's the meaning of cross multiplication. So I have 5 times z plus 2, and from the other side, okay, I have 3, and I cross over to the numerator, which is 3z plus 2, and I multiply again. So I very quickly jump from the given question over to this step. Okay, unlike earlier on, we ran through a number of steps before arriving at this. Okay, now that we have arrived at this, the remaining steps actually is the same thing. So I will take 5 to multiply with z and 5 to multiply with 2 when doing my expansion on the left side. Likewise, I do my expansion on the right side such that I will eventually get 5z plus 10 equals to 9z plus 6. So let me just grab a pen over here. 5 times z and 5 times 2, 3 times 3z and 3 times 2. Okay, then I will shift my 9z over to the left and my plus 10 over to the right. So I'll have 5z minus 9z equals to 6 minus 10 and minus 5z or negative 4z, sorry, not 5, negative 4z equals to negative 4. And then finally z equals to negative 4 divided by negative 4. Okay, so my remaining steps are actually the same. Alright, so what I want us to learn over here is this method of doing cross multiplication, which is much easier, okay, and lesser steps to follow. Alright, so when you do your homework or moving forward from this, please make sure you do this cross multiplication. I do not want us, okay, to go through very, very long steps, okay, which is what we saw. Let me just go back, okay, over here. Okay, I don't know how many steps there are over here, but definitely a lot longer and not as elegant as doing cross multiplication. Okay, as seen here. Right, we get the same answer, z equals to 1 as well. Okay, so I hope that you are able to understand this idea of cross multiplication, which is a much simpler, more efficient, and more elegant method itself. Next, we take a look at solving 4y minus 1.9 equals to 6.3. So in solving this question, it is no different from how we solve our usual equations, just that now we have decimal numbers, okay, but decimal numbers are just the same as numbers as well. So in trying to solve this question, we take this minus 1.9 and shift it over to the right side because our objective is to have our algebraic variables on the left and then after our numbers on the right side of the equal sign. So when shifting this minus 1.9 over to the right side, I'm doing a plus 1.9. So let's first just copy down the question first. And then in our next step, we have 6.3 plus 1.9 because we have shifted this minus 1.9 over to the right side. So with this 4y equals to 6.3 plus 1.9, okay, 6.3 plus 1.9 equals to our 8.2, which we can get after pressing our calculator, okay, and then this 4y over here is actually 4 times y, so to break away the 4, okay, over to the right side, it means that I need to divide by 4, so y would be equals to 8.2 divided by 4, and that lands us with 2.05 as our final answer after pressing into your calculator. Next, we take a look at trying to solve fractional equations. In this case, we have an example, which is to solve 9 over 2x minus 5 equals to 3. So to solve this example over here, okay, we apply what we learned about cross multiplication to try to solve. Okay, the whole idea in trying to solve equations is that we want to first get rid of the ideas of fractions in an equation. Then later on, it becomes more manageable for us to go about solving. However, in this case, what we see is that we have a fraction on the left, but our 3 is actually not exactly a fraction. Okay, however, we can definitely change this 3 into a fraction, right? I'm not sure whether you have a fraction in mind, how we can change this whole number 3 into a fraction itself. But let's first take a look by writing down the question itself. Okay, so what I want us to realize is that 3, okay, when expressed as a fraction, is actually 3 over 1, and that helps us to go about doing our cross multiplication, whereby I can take this 9 to multiply with the 1 and this 3 to multiply with the 2x minus 5. And that leads us to the next step, which is 9 times 1 equals to 3 times 2x minus 5. So 9 times 1 is none other than just 9 itself. Okay, and then 3 times 2x minus 5 is us trying to do our distributive law or our rainbow method, okay, whereby I take this 3 here to multiply with 2x and this 3 to multiply with this minus 5. Okay, apologies for this marking here. Alright, so therefore I get 6x minus 15 in my next step. Okay, Then with this 9 equals to 6x minus 15, what we need to do next is to shift things around, okay, up to your preference. Okay, so let's say I want to keep this 6x on the right side of the equal sign instead, okay, and I want to shift this minus 15 over to the left. Okay, so long as we have the x's all on one side and the numbers on the other side, okay, that will be fine. So what I'm going to do next is to consider taking this minus 15 over to the left side, and that will result in 9 plus 15 equals to 6x. Let me just adjust this arrow over here. Okay, so this minus 15, I brought it over to the left side. So I see that my algebra or my unknown x is actually found on the right side and my numbers on the left side itself. Okay, so now that we have arrived at this step, then I have still this 6 over here, okay, because I only want to find the value of x, not 6x. So this 6, I still need to bring it over to the left. Okay, so perhaps maybe before I bring it over, 9 plus 15 is just 24. Okay, and that is 6x. So this 6, I want to bring it over to the left side. And by bringing it over to the left, I'm going to divide 24 divided by 6, and that is equals to x. And therefore, we see that 24 divided by 6 is 4. So x is equals to 4. Maybe I can just rewrite it into this form, which is something we're familiar with. So x is equals to 4 is our answer. Next, we take a look at solving this equation here, which says that y plus 4 over 2y minus 3 equals to 2 over 5. This definitely fulfills the condition for us to do our cross multiplication, whereby we see a single fraction on the left and a single fraction on the right. So let's first just write down the question itself, okay, and then we do our cross multiplication like this, and we result in 5 times y plus 4 equals to 2 times 2y minus 3. Okay, then we do our rainbow method or our distributive law, whereby, let me just grab a pen, okay, 5 times y and 5 times 4 and 2 times 2y and 2 times negative 3. So our next step will be 5y plus 20 equals to 4y minus 6. Okay, then to solve, again, our algebraic letters all on one side, numbers on the other side. So I'm going to bring this 4y, which is a positive 4y. Let me just edit this. This is a positive 4y. Bring it over to the left, and then, okay, my positive 20 over here, bring it to the right. Okay, so I will have 5y minus 4y equals to negative 6 minus 20. Sorry, my writing seems to hinder my working. Okay, so plus 20 over to the right. Okay, so 5y minus 4y is just y, and negative 6 minus 20 gives us negative 26. And therefore, in this question, we get the answer y equals to negative 26.